Hi everyone. Thank you for waiting patiently for me to get the videos up. It's been a long week with the camera, but it's running now, so here we go. Oh, notes are a day late, but sorry about that. Hopefully you got a chance to do some on your own. It's great to be able to practice ahead of time and then check your answers with the videos. Okay, so this lesson is mostly word problems. You probably noticed showing you how we use average rate of change in real life. So this first activity, use the following scenario to answer question 1 through 5. So we have a new car. It's valued at $28,000. And when I see this equation in my head, I'm going, okay, equation means y equals mx plus b. So as I'm reading through the problem, I need to be looking for the two important things. Remember, the two things we said are important is the y-intercept. So think of the graph. That's the starting point on the graph, or if the graph's going down, it's the starting point going down. So when we had the self problem, it looked like this. When we did the melting ice statue problem, it looked like this. But what I want you to think every time you see the word equation is, I need the starting point, because that's B. And I need to know the rate of change, that's M. Those are the things I need to write an equation. So y-intercept, which as I said is the starting point, and the slope, which is the rate of change. So anytime I start a word problem and I see, oh, look, they're going to ask for an equation, as I read through the word problem, I start looking for those things. Oh, what was the value of the car at the beginning? Oh, how fast is this value going up or down? Because those are the things I need for my equation. So when I see this, I go, oh, there's a starting point. That has to be B. And then loses, gains, increases, decreases. Those are words we use for slope, how fast it's going down, how fast it's going up. So right away when I see loses, then I go, oh, look it, and they already gave me the slope. And I hope you understand that when it's loses, that means it's going down. So the M is negative 1750. So when it's gaining, increasing, that means the slope's positive. When it's decreasing, diminishing, losing, that means the slope's negative. So this is how you have to kind of train yourself to think now, since we started writing equations. And that's one of the biggest focuses of this module, as you can see if you did this packet. Okay, so let T represent the number of years since purchase. So this is, let's go ahead and write it over here. So number of years. Well, we could say number of years old, right? Because that's since purchase. And via T represent the total value of the car. So value in dollars. And the reason I always label that is because most of the time they want labels on the answer, like they're asking for rate of change. Rate of change is Y per X. So hopefully you understand that this is my X and this is my Y. And as I told you in another video, the X is given as lowercase almost always, and the Y is given as uppercase. Plus X is always first, Y is second. But there's a lot of reasons why you know that. So usually the function, which is Y, is named with uppercase. So that makes it easy to identify that. Okay, so now we're going to take Y equals mx plus b, and we're going to fill in. So I'm going to put it right here, right above Y equals mx plus b. And right below it, we're going to fill in what they're using for each of those. So what are they using for y? Via t. So replace it with via t. So everything will be in this form. You just have to use the letters, numbers they give you. M, we already identified. M is a slope, how fast things are changing. So that would be negative 1750. X is always what's in parentheses. So it's my little t. And then plus, B is always my starting point, my starting value, the base pay, whatever. And in this case, the base is 28,000. So that's what you have to train yourself to do every single time you see write an equation. Write y equals mx plus b, and then read the problem and get these values from the problem and just replace them. So now that we have an equation, now we can easily complete the table. Here's all the different t's. So for this first one, I'll show a couple of them and then we'll do them in the calculator. So this first one says, everywhere I see a t, plug in 0. So v of 0 equals negative 1750 times 0 plus 28,000. So you probably don't need to plug that in the calculator because this goes away. So you can see at 0 years old, the car's value is 28,000. On the paper pencil test, this was one of the problems we had on it. So I hope I can find one in Alex like this too when we have our test. Okay, so next is V of 1. V of 1 is, so everywhere you see T, replace it with 1. So V of 1 equals negative 1750 times 1 plus 28,000. So now we can plug it into our calculator. Whoa, easy, Flicka. So we have negative 1750 times 1 plus 28,000. And that is 26,250. So that's what the car is worth after 1 year. So $26,250. And then for the next ones, generally on a test, I kind of like you to write them all out, but just to save time on the video, we'll just use our up arrow. So use your up arrow and change the 1 into a 3. So key right, oops, change that into a 3. Oh, chihuahua, I think I hit 1 again, didn't I? It's kind of hard. I got to learn to watch the screen of the calculator, not the computer screen. So 22,750. Okay, then I can hit my up arrow again and change the 3 to 7. 15,750. And I'll show you a little trick when you're going on to the double digit numbers. Okay, so you do up arrow again, and we need to change that 7 to a 12, but there's only one digit there. So you type in the 1, and then you go second, and that INS button is insert. Put the 12 in, and then hit enter. Isn't that cool? So the first digit you type in. So we had 7, so you replace it with 1, and then you go second, and above the delete is insert, which is the opposite of delete, and you put your 2 in, and then you hit enter, and the rest of the problem stays. So 7,000. And then last but not least, we're going to change the 12 to a 15. So use your up arrow, make that a 5. And we get 1750. And I like to go till the problem ends because I want to know when the car is going to be zero. So when I see that I'm almost there, I think, oh, it's losing $17.50 a year. So don't you think on year 16 the car is going to be zero? And you'll see why, because they're going to concentrate after rate of change. Then they start concentrating a lot on X and Y-intercept. And when the Y is zero, that's your X-intercept. That's your ending point. So I like to go until it says zero. So let's go ahead and add in 16. And you'll see it is indeed zero because it's going down every year by 1750. So replace the 5 with 6 and boom. So here's the Y-intercept. This is the starting value. Here's the X-intercept. This is the ending value. So Y-intercept, remember, X is always 0. It's the starting point. X-intercept, Y is 0, and it's the ending point. So if you were drawing this graph up here that we were drawing earlier, this is what the car's depreciation would look like. It starts at this value, then after 16 years, it's worth 0. And those are two important points when we draw graphs. So when I see we're really close to the end there, I like to add it in. That way I have my, and let's go ahead and label this. I think that's a good idea. I have my X is 0, so this is called my Y-intercept. And here my Y is 0, so this is called my X-intercept. And you see they're going to ask questions about it later. They all do. So it's just kind of nice to be proactive and get it all done ahead of time. Okay, let's go ahead and answer these next 3 questions. So we need our table in the picture. What is the average rate of change? And they're calling it AROC now. There's a lot of names for it. Constant rate of change, which they call CROC. Average rate of change, which they call AROC. Rate of change, which they just call ROC. I don't know what's with all the acronyms, but just so you know, they're all the same thing for our purposes. Later on, when you get to calculus, you'll see they're not the same. Like, I'm not even going to go into it, but you'll see that there is a slight difference. But for our purposes, average rate of change, constant rate of change, slope, they're all the same thing. Find the slope. So from year 1 to year 3. So year 1 has this point, 26250. And year 3 is 22750. So do you kind of have an idea what the rate of change is before we even find it? Didn't we label this a slope? Yeah. So it doesn't matter which 2 points you pick. Remember how we said the slope of a line never changes? That's why we call it a constant rate of change. So whether I do it from year 1 to year 3, year 1 to year 7, year 3 to year 12, guess what my rate of change is going to be? They're all going to be the same, and they're all going to be this. So just, you should know that ahead of time, that a line never changes its slope. It has the same steepness throughout, so it doesn't matter which 2 points we pick. So let's go ahead and do this. So we have the second Y, 22,750, minus the first Y, 26,250, over the second X, 3, minus the first X, 1. And when we label that, or not label it, calculate it, we have 22,750 minus 26,250, and we get negative 3,500 over 2. So divide by 2. Oh, look at that. Wow. Who would have known? All of us, right? Negative 1750. And then remember, it's Y per X. So dollars per year.